Okay, in this video, I will try to solve LeetCode question 207 course schedule. I will first try to understand the question first and derive, for this video, I'll derive a brute force solution, and then we'll see in the subsequent video if I could optimize this solution. So let's begin by understanding the question. So there are a total of num causes that you have to take, labeled from 0 to num causes minus 1. So this means that if your num causes is 3, that means your labeled causes, or your ID of the causes, would be 0, 1, and 2. If your num causes is 4, then your labeled will be 0, 1, 2, and 3. Okay, and then you are given an array prerequisites, where prerequisites at I positions, there are two elements here, indicates that you must take cause B first if you want to take cause A. So what it is saying is that here A depends on B. So in order to complete A, you have to first complete B, then you can complete A. So there's a dependency here, and the output of the solution is to return true if you can finish all causes, otherwise return false. So let's look at example 1. We have the input number of causes 2, and the prerequisites is 1 and 0. So there are total 2 causes here. And if you were to represent this in a directed acyclic graph, it will look something like this, right? So in order to complete cause 1, you have to complete cause 0 first. So if I were to complete cause 0, then I can go ahead and complete cause 1. As a result, I can return true. So there are a total of 2 causes to take. To take cause 1, you should have finished cause 0. So it is possible. Let's look at another example where the output is false. So the number of causes is 2 because we have cause 1 and cause 0. And based on the prerequisites here, we could say that in order to finish cause 1, I have to finish cause 0. Okay, so this represent this. But the another prerequisite says a conflicting idea, because in order to finish cause 0, I have to finish cause 1. So this will draw another arrow here. So in a directed acyclic graph, if we have this situation, it is basically a cycle. And if there is a cycle, both cause will be waiting for each other to complete and never get completed. As a result, the output is false. So here it says that to take cause 1, you should have finished cause 0. And to take cause 0, you should have finished cause 1. So both causes are waiting for each other. As a result, both will never get done. So I will be going through the brute force method here, which is a depth search. After we have the solution of the brute force method, maybe we could optimize the solution. So in the brute force method, let me have another example here. We have cause 0, and let's say cause 1 and 2 depends on cause 0, and then cause 3 depends on cause 1 and 2, as well as cause 4 depends on cause 3. So here we would based on what we are seeing, we can just complete cause 0, 1, 2, 3, and then 4. So this will return true. And inputs will look like this, right? The number of causes will be equals to 5, because we have total of 5 causes here. And the prerequisites will look something like this. So we have cause 1 depend on cause 0. We have cause 2 depends on cause 0. cost 3 depends on cost 1 and 2. So cost 3 depends on cost 1. Cost 3 depends on cost 2. And lastly, we also have cost 4 depends on cost 3. So this will be our inputs. And the solution here would be to, maybe I can write down the solution here. So for every node, for each node or causes, we could do a depth first search. And in the depth first search, we will check, right, if the node is if we revisited a node, or a node is basically a cause as well. And then if we this will be a recursive call. And if we found that we are revisiting a node, if we have revisited a node, then we could just for this method here, we could just return true because we found a revisiting node, and else we could return false. And if this is true, if that means there is a cycle, the cycle exists. And if the cycle exists, ideally we want to return false. So we will have to return if our recursive method here return true, then we will finally we will have to return false at our main method. Okay, so let me explain, maybe go through step by step how this will look like. So in order for us to know whether this is a revisiting node, then we will have, let's say, a boolean here. I'm gonna initialize it as an array, and let's say we call it visiting, and we're gonna initialize all of them as false first. 1, 2, 3, 4, and 5. Okay, so we have initialized all of them as false. So we could do a depth first search here. Let me show you an example. So let's say we will start for each of the node or causes. So let's say we start with 0. Then I will maybe I can. So the index here, the index of the array of boolean, right, would be representing the causes. So this will represent the causes here. So index 0 means cause 0, index 1 means cause 1, cause 2, cause 3, and cause 4. So the main idea is that as we are going through the causes, we could use the index to identify the position of the array. So we could see whether, and then based on the position of the array, we could check the value. And if it is false, that means the causes have not been visited before. So just now we started at cause 0. Maybe let me use okay, cause 0. Let's say we start at cause 0, so this will become true. Cause 1, this will become true, and then cause 3, this will become true. Cause 4, and this will become true. So this is our first iteration of the depth first search. And then we also have our another path here, right? So we have cause 0 here, then cause 2, so 0 and 2, 3 and 4. Okay, so there's no cycle here. Then we will do cause 1, and then 3 and 4. There's no cycle here. We'll do cause 2, and then 3, 4. So 2, 3, 4, no cycle here. Then we will do cause 3, 4. There's no cycle here. And cause 4, there's no cycle here. And then we can return true because we don't see a cycle here. Then in this case, how do I know that there is a cycle? Let's say I have an example here. I have another edge here, another edge here. Okay, that means when I'm doing the depth search, when I'm at cost 0, 1, 3, 4. So 0, 1, 3, 4. There's no cycle. Okay, I backtrack. Then I look at 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, there's no cycle. I backtrack again. I do 0, 1, 2, 0, 1, 2. And then there's another cycle here that leads me back to 0. Then when I look at 0 again, this is already true because it has already been visited. So this will become, when we realize that there is another true here, there is a revisiting here, then we will return false because there is a cycle. So how it will look like is if the boolean for that particular cost, if the we will access the boolean for that particular cost is already true, then we could just return true because we found a cycle. Okay, so if we return true because we find a cycle here, then we will find out that the cycle exists. Then finally our main method will just return false. Okay, so okay, I think we have pretty much understand the question. Let's try to solve the question here. Okay. Okay, first I will initialize a adjacency list. So let me explain what this adjacency list is doing. I mean, this is a nested list. So so we have a adjacency list here, and we initialize it as a nested list. So it looks something like this, right? And then we have, okay, so this adjacency list is going to tell us the dependency. So let's say this is the first element is the dependent, and the second element would be the prerequisites. So in order to build the graph here, let me just remove okay. So in order to build this graph here, we have to swap the dependent and the prerequisites and build the adjacency list. So it will look something like this. So this is index 0. So index 0 will be the cost 0, and index 1 will be cost 1, and then 2 will be 2, followed by 3, cost 3, and then cost 4. So what we want is to build the graph into our adjacency list, so that for example, at cost when we are at cost 0, we have two causes that depend on it, cost 1 and 2, and then at cost 1 we have one causes that depend on it, which is cost 3. Okay, we can see it from this graph here, right? Cost 1 have 3, and then when we are at 2 we have cost 3 that depends on it. At cost 3 we have 4 that depends on it, and at cost 4 we don't have anything there. Okay, so the idea is that this adjacency list will tell us that after I completed 0, I can look at cost 1 and 2, and after I completed cost 1 I can look at cost 3. After I completed cost 2, then I can look at cost 3, and then after I completed cost 3 I can look at cost 4, so on and so forth. So this adjacency list will help us to navigate the graph. Okay. So once we have the adjacency list, we can also have our boolean here, the one that we mentioned earlier. So this boolean is the one that we mentioned here, right? We can initialize it as a list here. Okay, call it visiting, and we can just put in the nums causes here. So you need initialize all the boolean, and for all the index it will default to false. Then we will have to do for each of the causes. Okay, so for each of the causes we can do these, right? So I go to less than num causes and I plus plus. So for each of the causes we have to check if the causes is a cycle. So we could have we can have another method here. Basically it will return a boolean as well, and it will return true if there is a cycle, and otherwise it will return false. So maybe I'll just call this as cycle, and this will take in a few parameters, right? So first is the current cause that it is looking at, as well as the adjacency list. So let's copy this, which is nested this. Okay, and also the boolean here visiting. Okay, so for each of the causes, it will check that if it has a cycle. So pass I. Then we'll pass in the adjacency list as well as a visiting here. So if we found the cycle here, then we will just return if there's a cycle, then we want to return true, right? We want to return false. If not, then we can return true. So it will go through all the causes and then check if there's a cycle. Then now we could just implement our cycle here. Okay, so for our cycle, let's see. Our cycle will check if it is a visiting node. If it is a visited node, then we could return true. Okay, so if our visiting if the current cause is true, that means we have already visited these nodes, then we could return true because we have visited this node before or cause before, and as a result we found a cycle. Okay, and then if we return true here, then the overall the can finish will return false because there is a cycle. Okay, if there's no cycle found, then we can return true because there is no cycle. Okay, then we have to perform depth first search for each of the node here. So for each of the nodes, for each of the corresponding node that it depends on, we have, okay, I need to build the adjacency graph here. I think we still haven't built it. So for our prerequisites pair in our prerequisites, we have to first let's take out the dependent. which is the prerequisite pair at the index 0, as well as the prerequisite, which is the prerequisite pair at the index 1. Okay, so basically what we are doing is that we are taking out the first in the index, which is the dependent, and as well as the second, index 1, which is the prerequisite. So once we take out this, we can build our adjacency graph. So our adjacency graph will, maybe let me just rename this AD. Okay, our adjacency graph, we can get the prerequisite, which is index 0, and add the dependent into it. Add the dependent. Okay, so now we have finally built our adjacency list. So here we can use the adjacency list to find the next node that we can visit. So for our next course, in our adjacency list, dot get current cost, then we can continue to do our cycle. If has cycle for the next course, and given the adjacency list again and the visiting, then if there is a cycle here, then we'll return true. Otherwise we can return false. Okay, but before that, for this particular course, after we visited the current course, then we can make sure that our visiting at the current course becomes true. After we visit a course, we want to make it true, and after we backtrack, we need to make sure they become false. Okay, so okay, maybe let's explain how this looks like, right? So has cycle currently works like this. So we will first look at cost 0, right? Because we have 0, sorry, we have 0, 1, 2, and then 3, and then 4. So when we are looking at cost 0, then head cycle will be 0, and then followed by the 2 parameter here. Then after that, it will look at cost 1, so head cycle. So this is a recursive call, followed by the 2 parameter, which is the adjacency list as well as the visiting, adjacency list and visiting, and then head cycle, which will be the next one, which is 3, and then adjacency list and visiting. So if let's say there is a cycle here, then it will return true. And then if there's no cycle, then it will return false. Okay, so if yeah, so this is how the adjacency list works. Let me go back to the code. Yeah, so if there is a visiting, we'll return true. If there's no visiting, then we return false. Okay, I think that's about it. We can try to run this, see if it works here. Just so there is boolean visiting. We want to initialize with by causes here. If I'm not wrong, okay. New boolean number causes at line 30. Okay, we need to put the declaration. Okay, so there's an index out of bound here. At line 12. I see. So okay, because this is a list of array, I mean we can just for each of the pair we have to get the prerequisite, which is this index 0. We want to add our dependent. Index 0 out of bound for length 0. I guess we cannot start with index 0. In this case, what I could do is I think we cannot get 0. Let me try. Yeah, we cannot get 0 for this. In this case, let me look for a solution here. Since we cannot get 0, maybe we can just change this to a list of integer. Then we can just do this, right? And then so adjacency list, we can just access it via this. We could just put the prerequisite here. Then dot add dependent. Okay, let's see. Okay, so this will become a new array list. Is this the right way to do it? No. Okay, okay. Let me look for a solution here. I mean, ideally this should work. main list of integer. We have a nested list here, and then we can just get by the prerequisite here. Then we can just add a dependent. Okay. Okay. Let me get a solution here. Let me just use Google. Get the dependent followed by adding the prerequisites. Oh, we have to, okay. Let me see what's wrong here. So we get the dependent, which is the index 1. So dependence at index 1, then we add the prerequisites. So we want to add 0. Let me check, is that what we wanted? Not really. Don't think this is what we wanted. So let's so give the error here. Okay, it's completely empty. Okay, then I guess in this case, what we could do is we can just put in the empty array, right? So adjacency list, we just add the new empty array there. Okay, let's see. Okay, great. Okay, so we have the brute force solution. Let's try to submit. I think this will not submit because I think it exceeded the time limit. Yeah, time limit exceeded. We managed to complete 48 out of 54 test cases. And I think in the next video then we could see how what steps we could take to optimize this. Yep, I think that's all.